In today's video, we're going to be dividing terms with exponents. So we're going to use similar rules to the ones when we multiplied, except you're going to see a little slight difference when we divide. Again, we're going to expand these terms out. So we have a fraction here, 2 to the 7th divided by 2 to the 4th. I'm going to write it out expanded. 2 to the 7th is 2 times 2, 3, 4, 5, 6, 7 over 2 to the 4th, 1, 2, 3, 4. And what I'm going to do is cancel out, since any number divided by itself is 1, is cancel out and see what I'm left over with. 2 divided by 2 is 1, 2 divided by 2 is 1. And I cancel out, and I'm left with 2 3s. So it's actually 2 to the 3rd, which is 2 times 2 times 2, which is 8. Okay. So a very similar rule to when we multiply, but when we divide, again, we keep the base, right? Keep the base, it stays at 2, and we subtract the exponents. So 7 minus 4, which is 3. But it's always good to write it out expanded to see how you get that. Okay, let's look at another one. Let's look at 3 to the 6th divided by 3 to the 10th. All right, 1, 2, 3, 4, 5, 6. I don't know why I picked such a big number. 1, 2, 3, 4, 5. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Again, I'm going to cancel some things out. 2, 3, 4, 5, 6 of them cancel out. 4 are left, but they're on the bottom. Remember, anything divided by itself is 1. So it's not 3 to the 4th, it's 1 over 3 to the 4th. 1 over 3 to the 4th, because when I divide a number by itself, it's 1. And then when I have 4 numbers in the denominator, you have to leave those there. Now, say I have multiple bases. For example, I have 3 to the 7th. Now, let me pick a small number. 3 to the 5th times 2 to the 3rd over 3 to the 2nd and 2 to the 4th. Expand it out. There's 5 3s on top. 1, 2, 3, 4, 5. There's 2 3s. 1, 2, 3. On the bottom, I have 2 3s and 4 2s. 1, 2, 3, 4. Cancel them out. 1, 2. All right. Only those two cancel. 1, 2, 3. Cancel. So I'm left with 3 3s on top. 3 to the 3rd over 1 2 is only left over on the bottom over 2. And I can't simplify that any further. I mean, you could evaluate it, right? 3 to the 3rd. 3 times 3 is 9 times 3 is 27. So 27 over 2. So that would be a simplified fraction. Okay. But you can't combine them or when they don't have the same base. You only can apply these rules when the problems have the same base. All right. Let's look at another one. Let's look at ones with coefficients and letters. Okay, so let's look at 20, 10, x to the 5th, x squared. Okay, so the same rules apply like how we multiply, but when we divide the numbers out in front. So 20 divided by 10 is 2. And again, we have 5 x's on top 2 x's on the bottom. 2 of the terms cancel out. So you're left with 3 x's. So your final answer is going to be 2x to the third. Let's look at one more type of problem. Okay, there we go. So again, you divide the numbers out in front. 10 divided by 15. Those don't go into each other nicely. 15 doesn't go into 10, but what you notice you can do when you have a fraction like this is reduce it, right? 10 over 15, they're both divisible by 5. That reduces. So not always is the denominator going to go into the numerator. In that case, you reduce the fraction if it can be reduced. And they're both divisible by 5, so you get 2/3. All right, then we expand it out. Actually, I'm going to make this fraction bar a little bit bigger. I have 1x on top, 3 y's, 1, 2, 3. And on the bottom, I have 1, 2, 3, 4 x's and 2 y's. When I cancel out, I only cancel out 1x and 1, 2, 2 y's, right? So I'm left with 1 y on top, 3 x's on the bottom. So my final answer would be 2y over 3x to the third. I can't simplify that any further. Okay, so just similar to the rules that when we multiplied terms with exponents, we multiplied the coefficients and then kept the base, added the exponents. Same thing with dividing, just the opposite operations. When we divide terms with exponents, we divide the coefficients, we keep the base and subtract the exponents, right? So that's it for today's video. Work through these problems. If you have questions in class, please let me know. Thank you for watching.